Hello and welcome. I'm Martin Rostan and I would like to take you through a short introduction into the EtherCAT technology and the EtherCAT Technology Group. But why do we emphasize the feed bus so much? Why is it so important? Well, with a modern CPU, such as in an industrial PC, we have all the CPU power we've always been dreaming of. We can execute PLC code in no time. But if you combine such a fast controller with a legacy feed bus system or a slow industrial Ethernet technology, you end up like this car here, which has all the horsepower you can dream of, but you can't really make use of it. Why combine a PLC in the sub-millisecond range with a feed bus in the multiple millisecond range? Makes no sense at all. But wait a minute, we talk about Ethernet through real-time communication. There are three main performance issues. First, there's the bandwidth utilization problem. Then we have the stack delay problem, and we also have the switch delay issue. What do I mean by that? Let's start with the bandwidth utilization. An Ethernet frame is 84 bytes minimum. There's no shorter frame than that. If you use such a large container to transport a few bits or bytes, such as for an I/O node or for a drive, you end up with a very poor application data ratio. This is like taking a truck on the highway to deliver a letter. You can do that, but it's not the most efficient usage of the highway bandwidth. The next problem is the stack delay problem, and most people even neglect that. They don't even know about it, because the assumption is that by the time the frame has arrived in the node, it's there, it's done, it's processed. But industrial Ethernet protocol stacks, they tend to be big. We talk about more than a megabyte of code typically if we talk about Ethernet IP or Profinet. And accordingly, it takes time to process these large software stacks in small embedded CPUs. EtherCAT, in contrast, is much leaner. The maximum stack size is about 70 kilobyte. We're not talking about megabyte of code. And in case of digital I/O, it's even 0. Why? Because the chips have digital I/O on board and there's no software interaction for a digital I/O node in EtherCAT. And there's a company that has actually measured and published the stack delay times for a full-blown implementation of Profinet, Ethernet IP and EtherCAT on the same hardware and by the same people, so the same software skills. And you can see it can take up to 3 milliseconds to make the way through the software stack. In case of Ethernet IP, this cannot be neglected, and this comes on top of the cycle time. Then we have the switch delay. Switches are slow and unpredictable by nature, and switches typically work in store and forward mode. Store and forward mode means they receive the entire frame first. They check the frame check sequence in the end, and only if the frame is healthy, it will be copied to the next port. Why is that the typical approach? Because the IT guys like it that way. That's the only way they can filter out corrupted frames in their networks. That's why switches operate in store and forward, which is, by the way, the only standardized method by IEEE. Speaking of the IT people, I mean, we love our IT guys, but I think we all agree that they should stay where they belong to, and that's in the IT department. Now imagine you're deploying a machine based on an IP, Internet Protocol technology, such as Modbus TCP or Ethernet IP, and you're in the middle of the commissioning phase at your customer side. And all of a sudden the local IT guy shows up. What are you doing here? You're using IP addresses. I own the IP addresses in this facility, and now you're in trouble. Next thing he will say is, now my policies apply to your machine. Let's face it, IP, the Internet Protocol, typically is the threshold where the IT guys get nervous. Why? Because all the malware travels on top of IP. There's no Trojan or virus in the Ethernet frame. It's always on top of IP. Why? Because they need IP to get past the next router. They need IP for traveling. With EtherCAT, we're not based on IP. We're directly in the Ethernet frame. So we're avoiding the clash with the IT department. We're, so to speak, we're flying underneath their radar. That's why we call it the Ethernet feed bus. We make use of Ethernet technology, but we're as simple as a feed bus, and we're not considered an IT network by the IT people. By the way, you see these don't look like switches at all, but any two-port device in a switch-based industrial Ethernet technology has a switch chip inside, so it has to be considered a switch. and it also contributes to the cascaded switch issue that is typical for store and forward methodologies. Those three reasons that I mentioned are the reasons why most industrial Ethernet technologies are not really faster than the previous generation feed bus, which they are supposed to replace. Here you see a picture I found on the Profinet website, and it says RT, and RT stands for real-time. RT in Profinet provides similar real-time properties like Profibus. Now when marketing says similar like, it means not quite as fast. Now you may say, wait a minute, there is IRT, the motion controller option of Profinet. How about that? It must be faster. Yes, it would be faster, but IRT is pretty much the flag that the Profinet people are waving. Said, well, if you would need more performance, you could use IRT, but oh, you got mechanics. Mechanics is slow. You don't need IRT. RT is fine for you. IRT is pretty much vaporware. 2 years ago, the Profinet community announced that they will not further advance IRT, but replace it by a future TSN option of Profinet. And even Siemens is not using IRT for closing the motion control loop. They use DriveClick, their own proprietary version of 100 megabit Ethernet within their systems. So IRT is pretty much not existing. And on the right-hand side, you see a subset from a white paper from Rockwell Automation, a network with just 3 switches, so pretty favorable architecture, 80% bandwidth utilization, so a fully loaded network. And the cycle time for this network is 8 milliseconds. 8 milliseconds for 16 access, and the I/O update rate of 20 milliseconds. This is pretty much device net performance. EtherCAT is so much faster. We could do 100 server access every 100 microseconds if we had the processing power to compute the data for 100 server access every 100 microseconds. We don't have that yet. So EtherCAT is not a bottleneck, is not a thin tire on a fast car. It is not reducing the performance of an industrial PC at all. But what is the secret? Why is EtherCAT so much faster? Well, the secret is our unique functional principle. We call it processing on the fly. Instead of sending 1 frame per node per cycle per direction all of the time, EtherCAT is sending 1 frame through all the nodes. And everybody's extracting data from the same frame and inserting data into the same frame as well. In doing so, we share 1 frame, 1 overhead, maximum bandwidth utilization. You can also tell that this device has 3 ports, so it provides for a dropline connection right away. And you can tell the master is not very busy. It has to handle 1 frame per cycle, not hundreds of frames. This means we don't need a coprocessor in the master at all. Just an Ethernet port is fine, the rest is software. So we overcome the bandwidth utilization problem. We have little or no stack delays, and we don't have switches, so we don't have switch delays either. By the way, so far everybody liked the idea of not using switches on the field bus level. It means you don't have to buy them, install them, wire them up, power them, maintain them, replace them, and not configure them. Most switches today are managed switches on this level, which means you need IT know-how to configure them. I said everybody likes, well, almost everybody likes the idea. The switch makers are not very happy about it. With EtherCAT, we don't need them. Well, synchronization, a very important feature of a fast network, and the faster it gets, the more important it gets. And this is not only for multi-access application where you need to synchronize multiple access, such as in a robot, but even if you're controlling a single drive, keep in mind the drives doesn't give you velocity, it gives you position by its encoder. So equidistant reading of positions is essential to compute the proper velocity as input for your control algorithm. With EtherCAT, we use the principle of distributed clocks. The chips have clocks, high precision clocks inside, and we align them with each other. And now we base our sampling of data as well as our actuation of outputs on the local clock time rather than on the reception of the frame, which means we become independent from the jitter that the master may have. And our synchronization accuracy just depends on our local clock accuracy. All slaves are receiving an interrupt at exactly the same time, and it doesn't matter if the master picks up the data that was sampled at that same time a few microseconds later or earlier, this is totally doesn't have any influence on the synchronization accuracy at all. And the same applies to the output. The beauty of this approach as well is that we can use a slave as the master clock, which means we don't need a precise clock in the master itself. Industrial PC does the job, that's fine. And to show you the preciseness of the synchronization capability, I have a scope view image here with a network with 300 nodes and 120 meters of cable in between. This is the interrupt from the first node, interrupt from the last node, and the jitter is just plus minus 20 nanoseconds. Not microseconds, nanoseconds. That's the speed of light of a couple of meters. That's our preciseness in our synchronization capabilities with EtherCAT. Of course, we want to make use of the goodies from the internet world, from the IoT technologies, etc., from everything that is TCPIP based. So we can put a TCPIP stack in an EtherCAT device, but we put it on top of the EtherCAT chip. So yes, we are actually tunneling other Ethernet protocols over EtherCAT. In doing so, we ensure that we remain in charge of the performance and of the real-time capabilities of the network. We don't allow a non-real-time TCP/IP frame to screw up our real-time performance. But we can make use of any other Ethernet protocol on top of EtherCAT if we like. And if we look at the IoT communication technologies, EtherCAT is certainly the network of choice inside the machine control level, the EtherCAT device protocol. But we also use EtherCAT for machine-to-machine communication with the so-called EtherCAT automation protocol, which will be enhanced by TSN capabilities in the future to make it even more real-time. And if we need to speak to a non-EtherCAT system, we can also use OPC UA POP/SUB, also in the future enhanced by TSN on that level. OPC is also a good choice for the vertical communication towards clouds, technologies, or ERP systems, etc. And while some of these technologies are still evolving, EtherCAT Technology Group is not just sitting back and waiting. We're contributing actively. We shape the connectivity for EtherCAT. Just one example, one of our team has been a member of the IEEE 802.1 working group for TSN for 17 years now. This is since day one of the committee. So we are not just standing by, but we're contributing and shaping, and we can tell that we know TSN, we know what it's good for and what not, and how to use it. Topology. With EtherCAT, you can combine the nodes in any way you like. It doesn't matter. We can do line topology. We have no cascaded switch issue that limits us. We can do 65,000 nodes in the line if we like to. We can do drop lines, star, tree, any topology combination that you like. And with the ring topology, we even provide for cable redundancy. With EtherCAT P, the latest addition to the physical layer options of EtherCAT, we can combine 24 volt and even more power and data on the same cable. With standard 4-conductor cables, it's 2 times 24 volt, 3 amps each, and we can feed in standard data through a standard Ethernet physical layer into a junction box and provide power from there. And now you can power devices and communicate with devices over the same cable and the same connector. Diagnostics, very important part of the Fieldbus architecture. And those of you who ever had to troubleshoot a Fieldbus network, they know what it means if there are bit errors. A good Fieldbus technology will give you the information that there are bit errors, and it will say, you've got bit errors, good luck. With EtherCAT, every node is checking every frame, the checksum of every frame on the way out and on the way back. And if it detects a bit error, it will not only increment an error counter, but it will change the CRC in such a way that the others know this bit error has been found already. In doing so, we can not only detect bit errors, but we can localize them. Yes, we can localize bit errors. So an EtherCAT master will tell you there's an occasional bit error between node 58 and 59, check the cables there. What a simplification of diagnostics. Also, setup and commissioning is simplified with EtherCAT. First of all, we don't need MAC addresses, we don't need IP addresses. You don't have to set addresses at all. They're distributed automatically. You can even enhance networks and keep the old addresses with EtherCAT. And also the network planning. Don't worry about switches, don't worry about topology. Just put your network together any way you like. It doesn't really matter. We also reduce the costs because we need less hardware. We don't need switches or hubs. We don't need any plug-in card for the master, no FPGA, no communication processor, nothing. Ethernet port is fine. And on the slave side, we save money by using inexpensive slave controller chips, EtherCAT slave controller chips, which also handle all the sophistication of the protocol in hardware. Why are they inexpensive? Well, healthy competition. There's more than 12 makers of EtherCAT chips today. And among them, big names such as Texas Instruments, Renesas, Infineon, Arizona Microchip, etc. So there's healthy competition among them, which drives the prices down and gives our members inexpensive slave controller chips on the market. Speaking of members, EtherCAT Technology Group is still growing incredibly fast, is by far the largest FeedBus organization in the world, and has more than 5,300 members now, with more than 500 new members in the last 12 months. And we're not just a regional organization with a few overseas members. That's how we started, yes, with the founding members back in the days. But now more than 40% of our members are from Asia. We're Asia's largest FeedBus organization as well. We're America's largest FeedBus organization, and we are Europe's largest FeedBus organization. So it is a truly global organization. And it is an organization which has a large team. We have offices in China, in Korea, in Japan, North America, and our headquarters is in Germany. And most of those people are actually engineers, and they are there to help our members in implementing and deploying the EtherCAT technology. So you can actually call an ETG office and get help, not for the and get help with any EtherCAT related problem you may have. We can't support the many products of our members though. That's where you call the support of the supplier. Safety over EtherCAT, another important feature, and times are over where you had to separate the safety wiring from the FeedBus communication. You can integrate it all in one system with safety over EtherCAT. And you can even have decentralized safety master, a safety controller out there, combine it with a non-safe standard PLC. The flexibility of our technology allows for that. Stability, the versioning situation of EtherCAT. This versioning history here is actually not EtherCAT. By the way, this was Profinet versioning history. There's only one EtherCAT version, not one every year. What does that mean? It means we have enhanced the technology but never changed it. This is very important if you have to maintain an old FeedBus network. Those of you who have done this before, they may remember. First of all, you have to find out which protocol version was there in that network. You need to find the matching firmware version. Now you need to find a hardware device that is still running that old firmware. You need a firmware download tool. Oh, this firmware download tool version only runs on a computer with a serial port. Now you need such a computer. Then you find out that this computer needs Windows XP. Now you're in trouble with your IT department again. And it can take a day and a half just to prepare a device to replace it in an old FeedBus network. Not so with EtherCAT. You can take a device of today, put it in a network of 2004, and it will still work because we've never changed things. This is also helpful for the many vendors of EtherCAT devices. We have more than 2,000 registered vendors and by far the largest product variety in the industry. Let me emphasize in particular the large variety of masters, of controllers. With EtherCAT, it's not the case that there's one large company, one of the gorillas in the market, dominating the FeedBus technology and everybody else is just selling their slave devices into the accounts of the gorilla. We have more than 200 companies that have selected EtherCAT as their system bus, as their network of choice, as their default network. This is an entirely different way to embrace a FeedBus technology than just to sell slave devices to your competitor. And it also means that you get fully featured and reasonably priced master systems out there. So why do companies choose EtherCAT? Well, it is the fastest network for sure. But many just go for it because it provides such a flexible topology or because it's so easy to use. Others love it because it integrates IoT technologies so well. It is inexpensive. It provides functional safety. It is a stable technology which has no versioning issue, and it has the largest product variety in the industry. So why go for something slower just because it's more expensive? And you're going to say, wait a minute, what is he saying now? Well, we find that sometimes people are put off by the outstanding performance. Why? Because our mindset says that if something is super fast, there must be a downside. I don't know about you. Do you take a Ferrari for grocery shopping on a Saturday morning? Well, you may not have a Ferrari. I don't have one either. But I think most of us would love to have one. But we would not consider such a super sports car the everyday workhorse. Nobody just has a Ferrari and no other car. We need a weekday car as well. But EtherCAT has Ferrari performance, but it combines it with a Toyota reliability and a Tata price tag. So don't be put off by the outstanding performance of EtherCAT. The network cannot be too fast. And EtherCAT is not only super fast, but also reliable, inexpensive, easy to use, and has a large product variety. So I hope you make it your choice, and I thank you for watching.